1-2 study guide and intervention. We're going to talk today about lines, segments, and distance. So if you watched the video on 1-1, we had some definitions that we copied down. We're going to have to know those as we move into 1-2. A little bit different approach for me today. I'm not going to have you write down the bold statements and write exactly what it means, but you need to know what's going on in this top paragraph. So I'm going to kind of walk you through it. Again, my kids, kind of how we're doing this, we're putting 1-2, putting the title, lines, segments, and distance, and putting that today's Wednesday, August 19th. All right, here's what we're looking at today. We're looking at lines, and we're going to look specifically at parts of lines called line segments. All right, so let's just go through some terminology. Remember from yesterday or from 1-1, we talked about two capital letters with the line over it represent a line. So this says on line PQ, so right over here to the right. To say that point M is between points P and Q means that P, Q, and M are collinear. That's the first part of that statement. So here you go. We've got point M that is between P and Q, so they're collinear. Then here's what that means, since that's the case, that if you take segment PM, which is from here to here, if you add that to segment MQ, which is from there to there, you get segment PQ. And you can already see how we're going to get some algebra going in this class. We're going to take the little segment, add it to the little segment, and get the whole segment. All right, the next part of what we got to know today is this, all right, that we have line AC going on right there, line AC. And they say that AB and BC are equal. Okay, so we're looking at the actual distances from AB to BC. Now, specifically, it says that they're both 3. So they're both 3 centimeters. So we know that if they are the same measure, then these segments are the same distance. Now, in geometry, that means we say that segment AB is congruent to segment BC. I drew it over here as well for you to be able to get a little bit of a look at that. Okay? There's a congruent mark. So these little lines right here, 1 mark and 1 mark, means both of them measure the same, or they are congruent segments. If you hadn't heard of that, there you go. You've heard of it now. All right, jumping to example 1, says find EF. Completely easy when they give you 2 little segments. So the book walks you through what that means to find the distance of EF. You've got to add up segment ED plus segment DF. That's how we get there. Probably over teaching that a little bit. What do? If ED is 1.2 and DF is 1.9, we add them together and we get that our whole distance from E to F is 3.1 centimeters. I do like seeing the unit of measure on there if they give it to you. Okay? Pretty simple stuff. Little part plus little part equals the whole segment. Now, it doesn't equal the whole line, right? Lines extend to infinity and beyond, right? Thank you, Buzz. And so we're not going to find the distance of a line because we'd be counting for a while. All right, going over to example 2. Now they change it up on us, okay? They tell us, or they ask us to find X and AC, which is the whole distance of that segment. So you can see the work here, but we're going to set it up just like the last problem was. We're going to take the little part, which is AB, and that value is X. I'm going to take the other little part, which is BC, and I'm going to add them together, right? Little part plus little part, X plus 2X. And that equals the whole thing. So up here above our segment, they go from A to C, and that's 2X plus 5. Well, at that point now, we just got to do some algebra. Probably pretty good at algebra. You'll be fine. So remember, first step is simplify. In this instance, I can combine these like terms. A 1X and a 2X makes a 3X. Add them together. So now I'm here. 3X equals 2X plus 5. All right? I generally like to move the variables to the left side of the equal sign if we can. It works out really nice here. Remember, this is a positive 2X. We're thinking in terms of addition and subtraction here for this. So if I'm going to move it across my equal sign, I need to subtract 2X. If I do it on the right, I also do it on the left. You can see my line right here. 3X minus 2X is 1X. Remember, we're not going to write that 1. We don't have to. It's assumed to be 1. Over here on the right side, all that I had was just a regular old 5, and it's going to come down, and now I get X equals 5. Okay? If we stop there, we've done some of the problem, but we haven't done it all because we were not only told to find x, we were also told to find AC. Well, that's going to be simple. Look up here. From A to C, we know that as 2x plus 5. Well, I'm going to go substitute in that 5 right there for x. We know how to substitute in. We're just going to replace it. So 2 times 5 is 10, and 10 plus 5 is 15. So we know that line segment AC is 15 units. They didn't give us a measurement, so we're just going to leave it there. All right, pretty good. Not too bad. Jumping down, I'm in the exercises part, looking at number 2. They want us to find the measure of the segment. They changed it up on us. They gave us, in number 2, they want us to find from B to C, which is one of our parts. Well, they gave us the whole thing, which is 6. From A to C is 6. And they gave us from A to B, which is 2 3/4. Now, don't freak out about the fraction. Obviously, we can let the calculator help us if we need it. All right? I didn't give you a formula to find this, but it's pretty easy to figure out if you think about it. Usually, it's little part plus little part equals the whole thing. Well, obviously, if I know the whole thing and only one of the little parts, I should be able to subtract those and find the missing part. And that's exactly what you do. You can go on the calculator, 6 minus 2 3/4. Generally, for me, if it starts as a fraction, I want your answer as a fraction, but you can do it in your calculator as decimals. It's not too bad. That would be 6 minus 2.75. We'd get 3.25, which we know is 3 1/4, and it was in inches, so I left it in inches. Jumping down to number 4, they want us to find WX, and the only number they give us is the length of the whole segment from W to Y, which is 6 centimeters. Well, they gave us some congruent marks. Now note, there's 2 marks there. That's fine. That means that WX and XY are congruent segments. Well, if the whole thing is 6 and they're congruent, I can just divide 6 by 2, and we get that segment WX is 3 centimeters. This is a show all your work class. How do you show your work? Pretty sure if you get to 3 on that, I can assume that you know what's going on. All right, jumping down here to finding the value of X and RS if S is between R and T. So I came down here and drew line segment RT, and then I've got S in between them. Do I have it drawn accurately? I have no idea. What if those segments are congruent? I don't have it drawn accurately at all. All I've done is put S between, here, let me scoot it up. I've put S between R and T. That's all I know, all right? In fact, like on number 8, if RS and ST are both 4, I didn't draw this picture well for that. I have to redraw it. I believe this is number 7 right here, okay? Should have put that on here. This is number 7. So here's what we got. We got RS is 6X. I like to come write it right there by RS. ST is 12. And RT, so the length of the whole segment, is 72. They want us, again, to find X and then find RS. Seems pretty simple. I know little part plus little part equals whole part, so plug in the algebra. Little part of RS is 6X. The little part that's ST is 12, so I can add them together and equal it to the whole thing, which is 72. 6x plus 12 equals 72. Hopefully fairly simply for you. I got to move the positive 12. That constant needs to go to the other side. So I'm going to subtract 12 from both sides. That's how we do it, right? That gets rid of this. And then 72 minus 12 is 60. So on the left, I've got 6x. On the right, I've got 60. Well, we know now if I've got 6 times x, I get rid of that coefficient by dividing by 6, and we get x equals 10. Now, we're not done, are we? We found x, but we need to find RS. Well, very simply, we just need to plug in 10 for x. Not a whole lot of work to show here. 6 times 10 is 60, and there you go. We've got it. Jumping down here without showing you any work, it says determine whether each pair of segments is congruent. Well, this says, hey, is AB congruent to CD? Yeah, they're both 5. So the answer then would be yes. Like that, it's not even hard. Right here it says XY congruent to YZ. Now, XY and XZ are congruent, right? This is an isosceles triangle. But do they tell us that YZ is congruent? No, so we just got to put no. We don't know if those are congruent. They didn't tell us. Based on what they told us, the answer is no. Okay? All right, you should be good to go to your 1-2 skills. Remember, if you qualify for modified curriculum, there's that, and you can either go to your calendar or you can go into the assignments or into the modules part and click on that assignment. What I want you to do for this stuff is 1 through 10. I will teach you how to do the rest of the stuff on 1-2 skills for that in our next lesson. All right? This is going to be due, and I'm going to bump this due date back to next Tuesday, which would be, let me do some math. What is that, 25th? Double check me on that. I believe that is Tuesday, 8/25. If it's not, turn it in next Tuesday. All right? Thank y'all for paying attention. Online learners, I wanted to let you know at the beginning of 4th period, which starts at 10:39 on Wednesdays and Thursdays, I'm available on Google Meets for tutorials. You can let me know. If somebody that's in person is happening to watch this, you can stop by anytime. Come get the help that you need. Come see me. Thank y'all.